Hey guys, welcome to Algebra 2. This is second semester. We're in Chapter 8, Section 4 of the Big Ideas Math textbook. And what we're doing today is infinite geometric series. So what we have been doing is sequences that stop. So maybe they have 10 numbers, maybe they had 20 numbers, but they only had that many numbers in them. And today we are going to do a series that just keep going forever. They're infinite. And what we want to do is figure out how to find the sum of those. So the sum of an infinite geometric series is equal to the first term divided by 1 minus the common ratio. Now, here's kind of important. It's not going to be a trick question, but it's a little bit tricky. This is only going to work for us if, let me see if I can get my mouse working. There it is. It's only going to work if the R value is less than 1, and I mean the absolute value of the R value, the rate. So just the number itself, because if it's greater than 1, then there is no sum. Okay, so I can write with my finger, but I cannot write with my pen. We'll try it. It says, find the sum of the infinite geometric series. So first you need to identify the a sub, there it is, the a sub 1 term and the r. So the first term then happens when the I value is 1. So if you plug a 1 in for I, like we were doing on our last lesson, you would get 3 times 0.7 to the 0. So that's just 3. So your a sub 1 value is 3. Your r value, that common ratio, is 0.7. So according to the formula, the sum of the infinite geometric series is equal to that first term over 1 minus the ratio. So grab your calculator and use parentheses. So into my calculator it's going to look like this. 3 divided by parentheses 1 minus 0.7, close, press enter, and I got 10. So the sum of this series is 10. Okay, let's try again. Remember, we need the first term and we need the common ratio r. So just looking at this series, it's 1 plus 3 plus 9 plus 27 all the way forever and ever and ever. I have a first term of 1 and a common ratio of, well, what's 3 divided by 1? What's 9 divided by 3? What's 27 divided by 9? It's 3. Okay, go back a slide. What did you learn? You learned that if that r value is greater than 1, there is no sum. It's just going to continue getting bigger and bigger and bigger for forever. There is no sum because the r is greater than 1. Okay, now let's go ahead and try letter C. We need our a sub 1 and we need our r. So right now you should be doing in your calculator or in your head 3/4 divided by 1, and you should be doing 9/16 divided by negative 3/4 and finding that that r value is in fact negative 3/4. The first term's in front of us, it's a 1, so let's plug it in. The sum is equal to 1 over 1 minus negative 3/4. Okay, so in my calculator later this time I'm going to do 1 divided by open parentheses 1 minus open parentheses again negative 3 divided by 4, close those parentheses, and press enter. Alright, I'm going to catch up to you. and I got 0.57142. It's a bunch of yucky stuff. So I'm going to press math, enter, enter. And when I press math, enter, enter, I get 4/7. My sum is 4/7. Okay, let's try some more. It says find the sum if it exists. So what I know is that I need the first term and I need the common ratio. Now the nice thing is the common ratio is just -1/2, but I have to find the first term by plugging a 1 in. So if I plug a 1 in for n, 1 minus 1 is 0, so it's -1/2 to the 0, which is just 1. So this formula is 1 over 1 minus -1/2. And when you press math, enter, enter on that, you get 2/3 for your sum. So I should put a S equals. Okay, on number 3, we're going to need a sub 1. We're going to need the R. Well, the a sub 1 is 3. The R is 5/4. Stop right there. 5/4 is bigger than 1, and so you know there is no sum. That's how we do these. Okay, a pendulum that is released to swing freely travels 18 inches on its first swing. On each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance the pendulum swings? Okay, so what they've just done is they've told us that the first term is 18, and they told us the common ratio is 0.8. So if we want the total distance, that means we want a sum. So I'm going to do 18 divided by 1 minus that common ratio. And in my calculator, I got it. It would be 90, and this problem is talking inches. Remember, press pause a lot and talk to your friends about what we're doing. Okay, now we can use the sum of infinite geometric series here to write fractions in simplest form. Because a repeating fraction can be written as a sum, watch this. I can say that it is 0.24 plus 0.0024 plus 0.00024, and on forever. Okay, so if this is the case, then what I know is that my first term is 0.24 and my ratio is 0.01. So that would be 0.24 divided by 1 minus 0.01. Now, if you do this in the calculator, 0.24 divided by 1 minus 0.01, you're just going to get that repeating decimal that we were already playing with. So this really isn't a calculator problem as much as it is how to do this kind of math without a calculator problem. Okay, so come back to the denominator here and just do that. You can do that in your head. You're going to get 0.99. Now, if you simplify this, you can say it's 24 over 0.99 because all I did was move those decimals 2 places. And 24 divided by 0.99 is our repeating decimal. But the question is, can it be reduced? And the answer is yes. There is a 3 inside both of a 24 and a 99. So this answer is 8 over 33. Could you press math? Enter, enter? Yes, you could. But that is not what we're doing here. This is not how to learn to use the calculator in order to write a fraction. This is how to do it by hand. So I am expecting this work from you guys right here on how to do this by hand. Okay, let's move on and try another one. It says, what if in example 3 the pendulum travels 10 inches on the first swing? Okay, we'll go back in your notes to the pendulum problem. They're telling me that they want this to be a 10 instead. So that means this is a 10 instead, and we can just do that real quick in our calculator, and I got 50 inches. Okay, so we got 50 inches. All right, writing the repeating decimal as a fraction. Here we go. Let's make my pen thin again. So remember, this is 0.5 plus 0.05 plus 0.005 and so on and so forth forever, for infinity. That means the first term is 0.5 and the common ratio is 0.1. So this is 0.5 divided by 0.9, which is just 5 divided by 9, and that is already reduced. See how quick it is, and I didn't even use my calculator. All right, here is 0.72 plus 0.0072, and on and on. On and on. So we start with 0.72, 1 minus. That common ratio is 0.01. So 0.72 over 0.99 is 72 over 99. And now what we need to do is decide what we can reduce by. So I know 99 can be a 3, and I know 72 can be a 3. Whoops. That's a 3, I promise. So let's try a 3 first, because that's going to be 24 over 33. Okay, that can go again by 3, so I get 8 over 11. There you go. Okay, make sure you're pausing me and doing this by yourself. So first you break it up into a sum of an infinite series. That helps you identify the first term. That helps you identify how many zeros to put in your decimal place. So it's 0.13 over 0.99, and that's 13 over 99. And 13 over 99 is prime, because 13 is prime. So we're done. And we're done with this lesson already. Okay, get a partner. Good luck practicing.